All right, so today we are going to be doing equations of circles day 2. Agenda. Since I'm not here, we won't be going over any homework questions, but I do want to point out that on last night's homework, I totally forgot to fill in the circles for number 10 and 11, so don't worry about doing number 10 and 11 on your homework from last night. Sorry about that. Lessons and examples, and if there's time, problem-based task. If not, look at your calendar. I believe I have it due next week. All right. So in order to do today's lesson, we have to remember a topic that we learned last year in Math 2, completing the square. So I'm going to talk us through example number 1, 2, and 3, and hopefully by then it all comes back to you. So for completing the square, if you remember, the first thing that we need to do is we need to move the constant over to the other side. So I'm going to add 3 to both sides, making this x squared plus 8x equals 3. And I purposely left a blank because if you remember, I'm trying to make this left side a perfect square trinomial. So in order to do that, I have to take my middle term b, divide it by 2, and then square it. So that's 4 squared, which is 16. And now since it's an equation, whatever I add to the left side, I have to also add to the right side to keep the two sides balanced, which is great because now the left side is a perfect square trinomial. It factors to be the quantity x plus 4 squared. And the right side now, 16 plus 3 adds to give us 19. So now to finish solving, we would then take the square root of both sides, get x plus 4 is equal to plus or minus the square root of 19, subtract 4 and get x equals negative 4 plus or minus the square root of 19, and there's our answer. For today's lesson, we're not going to be going any further than that step right there, just leaving it as the quantity x plus 4 squared equals 19. The solving part is, again, just a review from last year. So in example 2, I'm not going to actually solve it. I'm just going to get that process of completing the square down. So again, I'm going to move that 1 over to the other side. So now we have x squared minus 5x equals negative 1. And then I'm going to subtract complete the square. So we take our middle term, negative 5, divide it by 2, and then square it. So that gives me 25 over 4, positive, because a negative times a negative is a positive. And yes, that's ugly, but perfect square trinomials work out nicely because they'll always factor to be your middle term divided by 2. And then on the left side, negative 1 is really negative 4 over 4, so we're left with 21/4. And again, last year in Math 2, we would take that step further, take the square root of both sides, actually solve. For today, it's more just the process that I want to get down. So our last example is a little bit different because our leading coefficient's not 1. So hopefully you remember. If not, hopefully me showing you brings back some memories. If our leading coefficient is not 1, we have to factor it out. I don't want to factor out the greatest common factor because I still want x squared and x. You just want to factor out whatever your leading coefficient is. 5 in this case. If it were 7, you would still factor it out despite 7 not going into 10. You would just get a fraction here, like in example 2. So now my leading coefficient's 1, and so now we do the same thing as before. I take my middle term, 2, divide it by 2, and square it. So that's 1 squared, which is 1. So I'm going to add 1 to my left side. But if you think about it, I'm not actually adding 1. I'm adding 5 times 1, right? Because it's 5 times that quantity. So on my right side, I have to add 1 times 5, which is 5, to keep the two sides balanced. So now my left side factors to be 5 times the quantity x plus 1 squared equals 12. And then we would divide by 5. And then again, last year from here, we would take the square root of both sides, subtract 1, get our final answer. But what we're focusing on this year is just that process. So now the question is, well, why the heck do we do all of that? And the reason why is, if we take a look at example 4, we're not going to do it right this second, but if we take a look at example 4, find the center and radius of a circle described by the equation x squared plus y squared minus 8x plus 2y plus 2 equals 0. I have no idea. I look at that and I'm like, what? Where's my center? Where's my radius? I have no idea. When something's in general form like this, it doesn't tell us any information. So in order to get that information, what is the center, what is the radius, I have to put my general form into standard form. And how we're going to do that is by completing the square. So how do we convert general form to standard form? Here are the notes. At this time, why don't you take a second, pause, write these down on a blank page. In section 561, if we have any left. Go ahead, pause, jot these notes down. All right, so I'm going to first start by grouping my x's together, grouping my y's together. So I'm going to rearrange this to be x squared minus 8x plus y squared plus 2y plus 2 equals 0. And now from here, I'm going to complete the square with 2 separate steps. I'm going to look at the x squared minus 8x, and then I'm going to look at the y squared plus 2y and complete both of them as though they were separate. So first things first, let's get rid of that 2. So I have x squared minus 8x plus something. And then I have, let's see, let's do blue. Y squared plus 2y plus something equals negative 2. Subtract the 2 over. So now let's complete the square with my x's. Negative 8, do that over here, divided by 2 is negative 4. Negative 4 squared gives me 16, so I'm going to add 16 to the left side. And if I add 16 to the left side of my equation, I have to add 16 to the right side. And now let's complete the square with our y terms. So we have 2 divided by 2, which is 1, squared is 1. So I'm going to add 1 to the left side, add 1 to the right side. So now my trinomial x squared minus 8x plus 16 factors to be the quantity x minus 4 squared. And again, I always know this because it's whatever I get after I take b divided by 2. Plus y squared plus 2y plus 1, that trinomial factors to be the quantity y plus 1 squared equals, now on my right side I have 15. And now my answer is in standard form, and now this is really easy to identify center and radius. So our center has the coordinates 4, negative 1, because remember the equation is minus h minus k, and our radius is the square root of 15. Because again, that's equal to our radius squared, so you want to square root it to find the actual radius. And there's our answer. So here's another example. right, so looking at this equation, I already noticed that my a and my b are not 1, so my leading coefficients of my x squared and my y squared terms are not 1. So we might have to complete the square similar to example 3 from our practice problems. But if I take a look at this, actually all of those numbers are divisible by 4, so since it's an equation, I'm going to just start this problem by dividing by 4. So now on my left side, I'm left with x squared plus y squared plus 5x minus 10y plus, let's see, 116 divided by 4 is 29 equal to 0. And now completing the square is going to be a little bit ugly because my b term here is not even, but a little bit better than before. So group the x's together. Group the y's together. And let's move our constant over to the other side. So now to figure out what to add, I'm going to take 5 divided by 2. This should look familiar. Square it. Gives me 25 fourths. If I add that to my left side, I have to also add it to my right side. And now I'm going to take negative 10 divided by 2, square it. So that's negative 5 divided by 2, which is 25. So I'm going to add that to my right side. I'm going to get a common denominator right now. 25 times 4 is 100. So that's 100 fourths. So now on my left side, this factors to be the quantity x plus 5 halves squared. And again, I know 5 halves because it's whatever b over 2 is. And plus y squared minus 10y plus 25 factors to be y minus 5, the quantity squared, equals, on the right side I have negative 29. When I convert that is really negative 116 over 4. So 25 plus 100 is 125, so that's positive 9 fourths. When I add negative 116 over 4 plus 25 over 4 plus 100 over 4. So now let's identify our center and radius. So our center has the coordinates negative 5 halves, 5, and our radius has the coordinates of 3 halves when we again take the square root. All right, you guys have the rest of the period to get started on the 561 problem-based task. If you finish it by the end of the period, you're more than welcome to hand it in and get your homework at that time. If you do not finish it by the end of the period, if you take a look at your calendar, it's due sometime next week. And make sure you get your homework from the substitute before you leave today. See you all tomorrow.